Right. So what I want us to think about today is energy. Now, let me just get my notes. Just checking to see how the organic people are doing before I dive into your notes. You know, your notes are going to take a while. Alrighty, cool. That should keep them busy for a little while. All right. So this external is all about energy. It's slightly different from what we've done previously in level 1. And it actually does pull some information from level 2, which I think is really cool. So when we talk about energy, what is it as a concept? Power, force. What else? Light. We're thinking about forms, types of energy. That's another type. So energy, as a definition, is the ability to do work. So that might mean moving an object, things like that. When we talk about the ability to do work, this falls into 2 categories. It's either active energy or potential energy. So active or potential. Active energy is able to do is able to do work without any changes. It's able to do work right away. Potential is energy that is stored. So it's not able to do work until it's converted into active energy. So when we think about active energy, you guys have gotten some listed down. So we thought about like mechanical, kinetic, which ties into a lot of your forces. We talked about what else? Radiant or light energy. Electrical, to name a few. We also have potential energy, which is stored. So that's things like chemical, like in our chemical bonds. You have things that are nuclear, so that's stored in the atom. You have things like gravitational potential energy. You also have things like elastic, as in like the rubber band. So those are kind of 2 things to keep in mind. All right, I'm just going to pause so I can give the organic people nice instructions. All right. So those are some things we have to keep in mind when we're looking at active versus potential energy. So these guys can actively do work. They can do something. These guys, they're stored. So the only way we're going to access the energy that's in here is if we transform it into a different form of energy. There's another way that you can also refer to energy, which is transferred. If we're talking about transferred energy, we're saying energy that stayed in the same state. I'm just going to bridge off of this idea. So transformed, we're talking about changing state or changing type. The other type is transferred. So it's same type of energy, but different object. So say, for example, you kick a ball and that ball hits another ball. So the energy is being transferred from one ball to another. It's still kinetic energy. Are we okay with that so far? All right. The next thing we have to keep in mind when we're talking about energy is that when it's doing this transformation or transferring, the energy is not created or destroyed. It is just being transformed or transferred. So what that tells us is that all the energy that has existed since the Big Bang is still here today. So I should start. Energy is not destroyed. Only transferred or transformed. Okay. That also means that all the energy created in the Big Bang is still here today. Something to keep in mind when energy is being transferred or transformed is that it can be changed into a type of energy that's not useful to us. So that's why we describe things as being like energy loss, even though it's not actually loss, it's just not in the system we want. Are you okay with that so far?
Yep.
All right, so we got to keep that in mind when we're thinking about energy. In this assessment, we are looking at some very specific types of energy. The energy that we are going to be looking at is we are going to be looking at specifically kinetic and gravitational. We will also be looking at thermal energy, which I forgot to write down. And we are also going to be looking at electric energy as well. So those are the ones we're going to be looking at in particular. Just checking to see if that was sure it was PT. All right. So when we're talking about kinetic energy, the other big thing about this assessment is going to be equations and learning how to do our equations. So for example, when we talk about kinetic energy, that is equal to 1/2 the mass times the velocity squared. So that's a formula you're going to be seeing. Another one you will see is the gravitational potential energy equation. They will give you all the equations on the assessment. So EP, potential energy, is equal to the mass times the gravity times the change in height. So when we are thinking about something, for example, dropping, we're going to be able to then connect these two ideas together. I'm just going to... So when we're thinking about energy transformations, just going to... going there. All right, I'm hearing better noise. We're going to take it back. All right, just going to pause this. E, this one. E equals PT. I need to double check what that one is, actually. That one I think.
Oh, it's like E cave.
Let me see. Look that one up. T. Energy transformed equals power times time. That one is. All right. Let me just plug in some other ones. So that is kinetic energy. That's gravitational energy. For example, you might think about like a bouncing ball or a dropping ball, I should say. So let's say I drop a ball from a height. It starts at gravitational potential energy, and then it becomes kinetic energy. Then it's gathering speed and speeding up. Yeah. I'm just trying to find this other one. Thermal energy. The equations we're going to be looking at are wrong color. E equals, so energy for thermal is equal to mass, heat capacity of water, and change of the temperature. And then there's also another one that goes M times L, which I need to figure out. And then we also have electrical energy. So we have power equals voltage times current. And then voltage equals current times resistance, I think. So we will unpack all those equations. T equals V I, and we also have V equals I and R. So those are some things to think about. So basically, we're going to walk our way through four main types of energy. Gravitational, which will tie into kinetic, so that'd be one kind of group. You'll do another section on electrical energy, and then we'll do another section on thermal energy, which is really cool because it ties into the chemistry. So, yeah. Last thing that I want you guys to then do so that way I can move on to the other groups, is I want us to think about energy transformations, and I want us to think about how those energy values are changing depending on the situation. So for example, if we have a dropping ball, so my system is the dropping ball. I want to think about my energy transformation and what's it becoming. So there's multiple ways we can express this. The first way we can express it is by arrows. So we can say that we have gravitational potential energy. It's normally abbreviated as that. And it converts it into kinetic energy, which is the movement. Now, that's not the only form of energy that it's going to be transformed into. When we drop the ball, it often makes a sound. So you'll also get a little bit of sound energy. And you get a little bit of heat energy as well.
Heat energy.
Yeah, because when it hits the ground, it's going to create a little bit of friction. So a very minute change in the temperature. So if you keep repeatedly hitting the ball on the ground, it will eventually warm up. But the reason why I need to specify that it's going to become these things is because these two here are not useful energies. That's examples of wasted energy, whereas this is useful energy, the movement of the ball. So that's one way you can express it. And also be mindful when you're dropping the ball, obviously some of that energy goes back into gravitational potential energy because the ball bounces back up. So when it interacts with the ground, it's going to have some force with the ground, and it's going to hit something that's going to oppose it, and it's going to jump back up. And it's going to keep bouncing up and down and up and down and up and down. So it's going to convert some of that kinetic energy back into gravitational, but not as much because some of it has been lost. Does that make sense? When you bounce a ball and you don't keep dribbling it, keep in mind that each time the ball bounces, so here's my ball, hits the ground, it goes back up, but it doesn't go up to the same height. Drops it back down, doesn't go up to the same height. So each time that the ball hits the ground and goes back up, it doesn't go to the same level until it eventually hits the ground and stops. So what that tells you is that some of that energy needs to be lost each time in order for the ball not to go as high. If energy was being conserved perfectly, then it would go back to the same height each time. So each time it goes down, it's going to be losing some energy in some way, most likely sound and heat. Because each time it hits the ground, it's going to make a sound. And on top of that, it's going to lose some to friction from the heat. So friction with the air, friction with the ground. So what I want you to do as your final task is I want you to think about the energy transformations. You could also do some graphs of like before and after. So you can have gravitational potential energy, you can have kinetic energy. So when we start initially, we have all of our energy as gravitational potential energy. When this reaction goes through and it hits the ground over here, all that energy has been transferred into kinetic. And if you want, you could say a little bit has been transferred to sound, and a little bit has been transferred to heat. But the idea is these two things will add up to that guy. All right, and then if you want, you can show it again happening, but in this case, it's going to be a slightly lower gravitational potential energy because these two energies are lost. All right, cool. So what I want you guys to do for the remainder of your time is I want you to think about these examples. I'll put them back on the board of the different energy transformations. So we've done the dropping ball. I want you to think about a girl swinging on the swing, going from maximum height to maximum velocity. There's also the rubber band stretching. Let's see what the other ones were. Rubber band stretching, turning on a flashlight, and heating up food in a microwave. So think about the energy transformation of those 4 examples. Okay? That should be us.